A completely new version of Telemetry Extractor, with dozens of new features, is coming out. This is a great opportunity to explain the differences between Telemetry Overlay and Telemetry Extractor. Both can read GPS and sensor data from a bunch of devices, like GoPro cameras, Insta360s, DJI drones and cameras, activity trackers, dashcams, and some more formats. Check the instructions manual to make sure your device is compatible. But then, Telemetry Overlay displays those data as gauges on top of the video. Gauges can be of many customizable types and styles, and the program then exports the finished video, both for publishing or for standard video editing work. Telemetry Extractor instead converts the data to a range of file formats. These can be read by endless third-party software options like Google Earth, Excel, GIS, programming languages, fitness websites, After Effects, and many more, thus enabling professional data analysis and manipulation. So in broad terms, Telemetry Overlay tends to be the right choice for consumers, video editing, sports, and any use case that requires sharing a video with data. And Telemetry Extractor is better suited for engineering, data science, forensics, GIS, surveillance, programming, and video editing done specifically in After Effects. There may be some overlap between these use cases, but this is the general idea. You can find plenty of tutorials for Telemetry Overlay in the video description below, and in the rest of this tutorial, we will learn to use Telemetry Extractor. This is a long tutorial. If you are only interested in a particular topic, you can find timestamps in the video description. The first step is to record good GPS and sensor data. With GoPros, make sure the GPS setting is enabled on the menu, and wait for a GPS lock before you start recording. For Insta360 cameras, either use one of the GPS remotes with a good GPS connection, or record from the mobile app with the GPS option enabled. The DJI Action 4 camera also has a GPS remote. With DJI drones, enable the video subtitles option in the Fly app. With phones or activity trackers, make sure you are recording to a compatible format like GPX. Other dashcams and devices may need additional steps, check their documentation and ours. Once in Telemetry Extractor, we will look for our footage with data. For example, DJI drone files. Here, we've got 3 consecutive video files, and it's important that they are consecutive parts of the same video. We will see how to handle non-consecutive videos later. And we could load just one of them or the 3 altogether. In some cases, DJI videos will have a separate SRT file with the data next to the video. That's fine, you just need to select the video. We'll drag the files into the program, and after a quick analysis, we are presented with the available data streams. Some of the common ones are pre-selected, like date and time and GPS-based data. We could change this selection, like pick camera settings, ignore speed, and selecting certain data streams enables a series of computable streams. For example, we could compute acceleration from speed data. Each data format has some additional options that you can learn about by placing your mouse over them. And let's import our selection. Telemetry Extractor reads the data and presents us with 3 visualizations. The GPS map on the right, data charts on the bottom, and a video player on the left. You can freely resize these areas to your liking. Moving through the video, we'll update our positions on the map and on the chart. And the video player has the standard controls like playback speed, audio levels, full screen. Moving the video to a separate window. Play and pause, obviously. In this case, we've got access to the 3 videos that we loaded at the top. And now let's explore the map. You can control it with the mouse and keyboard, like with Google Maps. And from its controls, we can change things like the zoom level when locked into our position, the map style with a range of designs, and satellite imagery. We can change the language, display the terrain as a 3D volume or not, change the color of our route, or use one of the data streams to tweak the color of the path. So if we select the altitude data, as we can see when displaying the whole map, higher sections will tend to be red and lower sections will tend to be blue. We could base the path color on speed instead, to show which sections of the route were faster, Or we could choose the time and the path color will simply change over time. Any of your streams will be available here. We will see additional options later on, but now let's have a quick look at the bottom charts. By default, we see a versus time graph with horizontal speed and altitude based on the video time. We see the unit scales on the left and on the right. And like with the video, clicking on the chart changes our position in the other areas. The same happens with the map, of course. You can click on a position to go there in the video. Let's explore different chart types. Instead of versus time, let's pick 2 dimensions. This means we will have a horizontal axis based on one of the streams, for example altitude, and a vertical axis with 1 or more streams. We can pick the number of GPS satellites, for example, add it to the chart, and this example will show us if there was any correlation between the drone altitude and the GPS signal. As you can see, the graph lines move up and to the right, so there was some positive correlation. The GPS signal was better the higher the drone was. In some cases, displaying points instead of lines may make the data more easily understandable. You can switch between the charts you created. And now let's see the statistics chart. We will include a bunch of streams in it. And this table is showing us statistics for each one of them. So we've got the minimum, current, average, and maximum values up until this point in the video, and then the total minimum, average, and maximum. Like before, you can click on one of the minimum or maximum values to go to exactly that point in the video. So you can easily identify extreme events. There is an additional type of chart, and it just displays text when one of your data streams cannot be represented as numbers, but that's not the case here. More chart types may be added over time. As we were saying before, in addition to the included data streams, we can compute new ones. Let's try that. And these are the streams we can create based on the data we have. For example, we can use the GPS data to understand the bearing, the direction the drone was traveling to. Some computed streams will have additional settings, like in this case the minimum distance between samples we want to take into account, so as to avoid mistaking small inaccuracies with actual movement. And the exact setting you want here will depend on your activity and data quality a little, so this may require some trial and error. And we can compute another stream, like the 3D distance, which means how far our vehicle has traveled, including altitude. We will add both the distance and our bearing to the new chart. And these are the results. If you don't like them, you can remove a chart to avoid clutter. And finally, the most important step, extraction. Here you can select your output format. GPX works great for time-based mapping activities. CSV is a spreadsheet for software like Excel, Numbers, Calc, Sheets, and so on, but also GIS software like ArcGIS. KML is good for static mapping applications. MGJSON is designed for Adobe After Effects. JSON is perfect for integrating the data with programming languages. And GeoJSON is compatible with some mapping software options. Let's give this a try on Google Earth. And while GPX is great for mapping applications, the online version of Google Earth doesn't support it yet, so we will pick KML. The program has selected a series of data streams automatically for us. We can see its units, the data frequency, and where within our project we have already used those streams. We can remove them if we don't want them in the final export. And here is a list of other suggested streams based on our charts and map selection. So let's add, for example, horizontal speed and the bearing direction that we computed. And we can also select streams that were not suggested to us, both native and computed. Pick their units and add them to the export. The next step is to pick our frequency. We can choose the native frequency of the data, in this case 1 sample per second, and all the streams have the same frequency, so we don't have to pick. Here is an option to choose our interpolation method, that is how to compute new samples if the exported ones do not match the original ones. Auto tends to work well in almost all cases. And we could also change the exported frequency, for example to export 10 samples per second instead of just 1, or for example 0.1 to export 1 sample every 10 seconds and have a smaller output file. We could also pick the frame rate to create samples that match the frames in our video. Finally, some more options like whether to overwrite existing files, whether to save the data file next to the original one. Force standard means changing some of the data units and structure to create a more compatible file, for example the type of KML that other programs expect. And include time means the program will add the video times as an additional data stream. We can change the output name or save it to a different folder if not using the original path. And we're ready to extract. Later on, we will see how to use the extraction queue to extract many files at once. But for now, let's just extract this one file. The process is very quick. And here it is, our file next to the video. Let's put it to the test on Google Earth. The desktop version will give you lots of creative options, but let's try the online one for now. We will create a new project and load a local KML file. Navigate to our data file. And that's it. We've got our route with elevation on Google Earth. The desktop version will probably give you more creative options. You can find tutorials on interesting Google Earth use cases in the description below. And if you didn't want to show the elevation profile in 3D, you would need to edit your extracted streams and remove altitude. Let's now explore more advanced settings. For that, we will create a new project. Navigate to the GoPro data. Again, these are strictly consecutive files, as we can see from their identical file name endings. We'll drag them both into the program. And the range of streams is similar but different. We've got some more options. We can accept the default selection. And with GoPros, we can also import highlight tags. These are tags created by pressing the menu button on the camera while recording. Again, this takes a moment to load. But straight away, we see there's a problem. The GPS path doesn't make sense. Apparently, the camera recorded some bad locations, and we can try to get rid of them with filters. For example, from the bottom of the map options. Every camera format may enable different filters, and one of them is dilution of precision. To put it in simple terms, this is the GPS error. If we enable the filter, any location worse than 6 will be discarded. And once we fit them up to our new route, it looks much better. Filters don't make miracles, but they can save a project where most of the data is good and you just have some bad samples. With other sources, you will see filters like the number of satellites and also wrong speed. If you think about it, going from the equator to Europe in the few minutes of this video would require an incredibly high speed, so enabling the wrong speed filter means we will ignore any GPS positions that result in such high speeds. Always set a very generous margin between the wrong speed filter and the maximum possible speed of your activity. For example, if a car does 100 km per hour, pick at least 200 to make sure you're not ruling out good samples. The same filters are available for charts and for extraction. With this project, we see both the versus time chart and the map are full of markers that were not there before. These are the GoPro highlights. Like with many other things, we can click on them to go to that moment in the video, both from the map and from the chart. Something similar to filters is smoothing. Let's create a new chart to demonstrate it with the Accelerometer data. As you can see, the data is quite noisy, even if we display it as dots. So to make better sense of it, we can add smoothing. This will average samples over the given amount of time to make data trends more obvious and reduce noise. Also down here, we can bring up the trim controls. So from our entire timeline, we can choose an in point to discard any data that came before that moment, both in the charts and in the map. Let's pick a darker map to make it more obvious. And we can turn the trim point off and on to visualize the change. And the same with the trim out point. We can navigate to the trim points with the arrows, or set new ones on our current frame. When extracting data, for example, a simple CSV file, we will have the option to trim or not the data based on what we did on the view section. Instead of that, let's export a comprehensive CSV to explore other use cases. We'll pick some essential streams like latitude, longitude, and altitude. The wrong speed filter is preserved, but we could also add it from the Add Stream section, and we will compute new streams. For example, pitch, and roll to see the orientation of the camera. The availability of these streams will depend on your camera model or the specifications of your hardware. Let's also pick the accelerometer sum, also known as g-forces usually. And for the frequency, the time data will give us 10 samples per second. So maybe to make it more interesting, let's pick pitch, which will be 25 per second. The accelerometer was recorded at 200 Hz instead, and maybe that's overkill for this test. Interpolation will happen, but auto is fine. We'll save this next to the original path, and it's instantly done. We can open the CSV file with our favorite spreadsheet software like Microsoft Excel, Apple Numbers, Google Sheets, or LibreOffice Calc, and do typical spreadsheet operations like visualizing charts or creating new columns with math formulas based on the existing data. There are plenty of tutorials on how to do these things. Another popular use case of both Telemetry Extractor and CSV files is GIS software, for example ArcGIS. Here we've got a very basic project, and we'll go to the Geoprocessing tab, usually on the right. We'll search for the XY table to point tool, and here select our CSV file for the input table field. The program already understands our essential data fields, longitude and latitude, and we could also select altitude manually if needed. Let's run the tool, and in a few seconds, it adds our route to the map. If we zoom in, we will see how our data points preserve all the other properties from the CSV. There are endless use cases for GIS software, including some that involve syncing the video with the data, so you can check the documentation that covers your needs. A special case is 360 videos. Many cameras do not record to 360 formats that Telemetry Extractor can visualize properly out of the box. The geometry would be broken, like Insta360 INSV or GoPro's .360 format. But we can use their software to convert the video to equirectangular format and visualize it in 360 within Telemetry Extractor. In this case, we will use Insta360 Studio. For GoPro Max, we would use GoPro Player, and so on. Just drag the video into the program, and it's a 3D one, as you can see. And press Export. Choose Export to 360, and make sure you are exporting next to the original video and with the same file name. The default settings are normally fine, and let's export it. This will take a while. Once it's done, the video must be next to the original with the data, and dragging it into Telemetry Extractor, the process goes as expected. Reading accelerometer data from Insta360 is slow, so we can ignore it this time. Now we've got a 360 video player, synchronized with the map, and with the data as expected. You could pick a different 360 projection if your video was filmed differently, or disable it to see the entire frame as equirectangular. But 360 is most useful here. Some other video formats will struggle to be played natively. In this case, you will see an option to optimize the footage. This means creating a more playable copy. Once the process completes, the video becomes visible. Let's move on to the extract section. As you can imagine, if you need to repeatedly extract the same type of data, you can create presets to make your work faster. Let's, for example, create one for CSV extraction, pick a handful of streams, maybe compute some as well, like bearing, and slope. And once we have our stream selection, pick our frequency like we did before. Maybe we always want 10 samples per second, and we don't want to create intermediate values, just copy them. So we'll pick nearest for interpolation. We can choose our favorite options, like saving next to the original path and not including a time stream. And now the preset is ready for saving from the top right corner. We just need to give it a name. And it's saved. Let's create another one. Maybe if sometimes we want to create JSON files, and we'll pick some streams, like the native GPS time, say speed, but with different units than the suggested ones. And we can compute distance. This is just an example. With these 3 streams, we can decide to export always at the frame rate frequency and have auto interpolation, which tends to work well. Pick additional options. We will not force the standard, and save it as JSON with speed and distance, for example. We've got these 2 presets, and we can select one as our favorite. It will be applied automatically for every new project. We can also apply a preset at any time from the top right corner. And then just extract our data. This time instead, we will add it to the extraction queue to process it later. We can do the same with our JSON preset, select it, and add the output to the queue. After adding as many projects as we want, we could start the queue to export them all. The queue items can be sorted, and also from the queue, we can access the batch loader feature. This will allow us to select many files, consecutive or not, from the same camera or from different devices, and add them all as projects to the queue with one of the extraction presets. Here we will select all the files we've been working on, so the DJI flights, the Insta360 video, and here we don't need to select the equirectangular MP4 because we are not previewing the video, we just want the data from the original file. When you have more than one Insta360 files for a single video, the GPS data tends to be in the one with a 00 in the file name. And the 2 GoPro files. The batch loader will analyze the files and present us with this suggestion on how to join them. It has grouped them based on the type of telemetry and their dates and durations. So the result would be 3 separate extracted files. From the right, we could change this decision and extract the files separately, potentially sort them to create a different order. And we've got buttons to unlink all the files, link them all if compatible, a low RAM option, which may be necessary when working with thousands or maybe hundreds of files, but check your results as this is experimental initially, and of course our preset selection. The favorite one was picked automatically, but we could switch to a different one. Once we're happy with this, we can queue these 3 projects. They're now on the queue. And starting the queue, we'll extract them all in moments. Finally, and before explaining how After Effects templates work, let's see some more basic functionalities. I'll just load one of our projects and see how now from the initial load section, we can see lots of information about our source and the files it is composed by. From the top table, we also have an option to extract static metadata. Things like file information, camera settings, or other information device manufacturers may record in the file header, like GoPro highlights. On the top right, we've got the general settings, like the folders we are saving data to by default. There is an option to delete cache, which you can use after working on a project that required video optimization. We've got the default units that the program will pick for things like charts, but you can also change them manually at any time. We've got Mapbox keys, which you can use to display your custom map styles. You would first create them in Mapbox Studio with custom KML shapes or imagery and geographic data specific to your professional field. You would then create public and private Mapbox tokens and paste them here. Something similar applies to terrain altitude. If you want to compute altitude data for a route based on terrain elevation, you can include a Google Maps API key here. All these options and many more items in the program have information tooltips that you can bring up by placing your mouse over them. The same applies to the options below. And finally, we've got optimization settings. This only affects videos that you need to optimize in order to preview them within the program. The software includes a help section with the full manual, video tutorials, a manual for the After Effects templates, and some more information. Here's a direct access to the export queue, the button to create a new project from scratch, and some notifications about updates and potential warnings. And now let's see how to create a video with data in After Effects. This is an advanced topic, and this workflow is only recommended to advanced video editors that are already proficient in After Effects. For most video editing use cases, I strongly recommend using Telemetry Overlay instead. It's way easier, it's faster, it has more features designed specifically for video editing, and it is compatible with professional video workflows thanks to transparent video exports. See links for tutorials in the description. Since many of you will stop watching this tutorial here, let me remind you that you can ask questions in the comments, Join us in the Facebook group or send support tickets by email, as the software comes with 1 year of updates and support. Make sure to follow this channel to see what comes next. For Adobe After Effects projects, we will pick the MGJSON format. The program has pre-selected a large number of streams because the included template supports them. You can remove any that you are not particularly interested in, or add additional ones you want to display in After Effects. The native frequency of each stream will be fine, and for After Effects we don't need to interpolate here. Each stream will have its specific frequency, even if the 200 Hz of the accelerometer may be overkill. So in some cases you may want to pick a lower fixed frequency, like 1 Hz or 10 Hz, to reduce file sizes and improve performance in After Effects. Again, we'll pick some of the standard options and extract our file, which is next to the video now. If this is your first time exporting to MGJSON here, you will also need the template, and there's a button for that. Let's just copy the template to our video folder, uncompress it, and open it to launch After Effects. The template already has sample data and a wide range of gauges, all placed in a main composition for demonstration purposes, but let's import our video. We'll create a composition with it, and I'll create a bottom area to place gauges inside of. We can make it semi-transparent, and go to the main composition to pick one of the gauges, for example the GPS path. Let's copy and paste it, and move it to the bottom. Now from inside the GPS path composition, we can import our MGJSON file, place it at the bottom of the composition, and click on the control layer. This will give us a wide range of options in the Effect Controls tab, and the first one is the MGJSON source. We just need to select our MGJSON layer, and the path automatically becomes the one from the video. Let's increase its size a little for visibility. And again, from inside the composition and the control layer, we can tweak things like hiding coordinates, make the path thicker, and the size of our position. We can make the path white to make it a bit more elegant. Choose whether to display it just partially or in full. And there's many more controls that you can play around with or check the manual. The process is the same for other gauges. So let's pick speed, for example, place it in our video composition, move it to any position, if you need gauges to be bigger than 100%, you can do this without pixelation by enabling collapse transformations, although this may decrease performance for complex gauges or if you're using many gauges. Again, let's replace the sample data with our real data, place it in the composition, select it as the MGJSON source from the control layer, and tweak things. We can change the maximum expected speed, change between metric or imperial units, and play with the angles of the gauge so it looks better in a corner. We've also got too many labels, so we can reduce them. And that's looking much better. Of course, with this being After Effects, the possibilities are endless. These are just some quick examples of what's possible. To try something a little more advanced, let's pick a gauge design and use it to display a different data stream than it was initially intended to. This way you can potentially use any of the designs to display any of the data streams, and you can also start to learn how to design your own gauges with any After Effects elements. Let's copy it and paste it on our composition like before, and rename it to Custom Speed, for example. Place it in our gauge area, and double-click to enter it. I'll add our real data, and select it as the MGJSON source as usual. If this was displaying vertical speed, we would want small units like meters per second. Let's use large units though, kilometers per second, because we will display horizontal speed instead. As you can see, if we expand the data within the MGJSON file, all our data streams are listed, along with their units. From the composition options, we can unhide all the hidden layers that are composing this gauge. Here, as a general rule, orange layers means you can touch them, but be careful with them. Red ones means don't touch them. But of course, this depends on your skill level within After Effects. Big changes will require scripting. One of the orange layers is Stream Selection Label. If we unhide it, we see how it says Ascent. That is the vertical speed stream, but our horizontal speed stream is called Speed. So we can just edit this text to say Speed, and now the data is pointing at the horizontal speed stream. Let's increase the maximum value considering that we are on a car. And we can use imperial large units like miles per hour. Remove the decimals as they are not as important in this context, and change the minimum speed for 0. This makes sense now. And you can apply a similar process with any of the gauges and data streams. However, the displayed values have units and unit conversion. So if we were picking a stream with different units, displayed values would not make sense. In that case, the easiest solution would be to hide all the labels and create your own text layer. Open its properties, choose text, and while pressing the Alt or Option key, click on the stopwatch for source text. This is the After Effects scripting input field, and the easiest way to use it is to grab the pick whip and link it to the property you want to display data from, in this case to the speed. That's already showing us a value, but it doesn't look great because of the decimals. So let's do some basic scripting to fix that. If you're familiar with coding, what we're writing here is basic JavaScript. We will store this value in a variable and precede it by the plus sign to make sure it's stored as a number. Then on the last line, pick only 2 decimals by using the toFixed function. We could do 1 instead, or 0, or 10, whatever you prefer. To make this more meaningful, we can add text with the units, which in this case we know are kilometers per hour in the original source. If you wanted to convert this to different units, like miles per hour, you could look up the formula. Here it's just a multiplication by this value. So before returning it, we'll do value equals value times that number. And we'll change the label to miles per hour. As with any After Effects layers, you can change fonts, colors, sizes, movement, and anything you can imagine. This is working on our final composition, and it's a very tiny example of what you can do with After Effects knowledge. If you know After Effects scripting, you can move shapes based on the data, change colors, animate lines, apply effects, etc. It's a very interesting topic and there are plenty of tutorials online. As you can see, the range of gauges is much wider than that, and you could create your own styles as well. As mentioned, there's a specific help section for this. And again, we've got the comment section, the Facebook group, and email support. I hope you found this interesting. This new version of Telemetry Extractor has been in the making for a long time. It will be improved over time as well with new features, like you've seen with Telemetry Overlay. Stay tuned to see what comes next.